Okay, so trig quiz 3 again, kind of important. You did this right. If you didn't, well, sucks to be you. Okay, so when we go to graph these reminders, we're going to have 5 points that we're labeling each time. I mean, if you want to put more, you can, but you don't need to do any more than that. So when we're trying to label the different parts, there's not a whole lot to label in this first one. Because basically all you're looking at is you have an amplitude of 4, but remember that negative means we're basically going to reflect our graph over the x-axis. We'll talk a little bit more about that in a minute. But as far as the other parts go, I don't have a b value that's going to change my period, so I just leave that alone. I don't have any phase shifts that are going on, at least with this one, so that's not a big deal. And then we get to a concept that's a little bit interesting to think about. Okay, vertical shift, there's none, okay, not for this one. But there's another part of this we can think about. We'll do that in a second. So if I was going to graph this, I notice that my amplitude's 4, so I've got my 4 and my negative 4 working here. And since my period is 2 pi, I know that's going to be the last value that I'm dealing with. So how would I go about getting the values in the middle? Split that in half, in between 0 and 2. There you go. And even if that didn't click right away, you could say between 0 and 1 or 0 and pi is pi over 2. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Yeah.
Wouldn't you pretty much just be like 1 over 2 and then like the whole number and then just put pi in place for that?
Yes. You absolutely could look at it as 1/2, 1, 3/2, 2. Yeah, absolutely. That's all it is. So when I get that in there, then of course I have to remember something else, which is not in my unit circle, but what we've chatted about. You've got to have a base feeling for where your sine and cosine values are. I mean, even this one that straight up is the exact same one, so I mean I have all the values here. But knowing that my cosine is the one that's not starting at 0, and then here, normally, I'd say, ooh, I'm going to start at 4. Negative. Start negative. So minimum, 0. Maximum, 0. Minimum. And this is not a V. We're not drawing absolute value graphs. These are sine curves. Okay. Now to get back for a second to this whole thing of a center line. Okay. This is going to become more prevalent when we get into the next part where you're going to have graphs and you're going to have to come up with the equations for them. The center line just means where's the middle? Well, the middle, if I have a max at 4 and a minimum at -4, my center line would be at y equals 0. That's something that's kind of a preview of what we're going to be getting into. For now, if you just say vertical shift none, I'll live with that. Okay. But if you want to start getting used to what that center line verbiage is, that's what that would mean. Okay. But again, that was me on the nice one. Now we're going to be a little more interesting. Because I get to this next one, I'm like, oh, what's going on here? Vertical shift. Up 1, that's not my amplitude. That'd be right in front of sine. So my amplitude's just 1. My period, I still don't have a value in front of my angle measure. Okay, I was at least nice there. I left that as 2 pi. And then what direction's my phase shift going to be? Okay, right. So right, pi over 4. So now this is how I would tackle it. If you want to see this all done without using any extra points or anything and maybe using a chart, I'll leave the other video up too. But here's the way I like looking at it instead. I'm going to forget about these for a second, and I'm just going to graph this like it was just the sine graph. So if that was true, sine graph with a period of 2 pi, would look something like this. And I'd say, okay, get my values in here. And basically what I would do is I'd say, okay, normally sine would start at 0, and I would just go 0, 1, 0, -1, 0. But I'm just going to put the points in because I'm just kind of getting myself a reference to work with. Once I look at those, I'm like, okay, so now I need to move them up 1, which isn't a problem. But wait a minute. Write pi over 4. I don't have any pi over 4s anywhere. Well, I can. Because if I start looking at these, I'm like, hey, what's between 0 and a half? 1/4. What a coincidence. Pi over 4, so 1/4, 2/4, 1/2. 3/4, 1. 5/4. 6/4, but it's been reduced. 7/4. 8/4, but it's been reduced. 9/4. Here's how that helps me immensely. Because now I can do my 2 movements, and this shouldn't be hard. So I'm going to move right pi over 4 and up 1. Move right pi over 4 and up 1. Move right and up, right and up, right and up, and connect the dots. Now again, if you're comfortable enough that you can get your base graph in your head and then start moving everything, awesome. If you're more visual and would like to see that done as a chart where you do it and then you move the values, that's what I have on video already. I like this better because I think it's going to go faster and it's a little bit easier to deal with. So, just saying. So that probably, well, it's not the trickiest one 4 is, but it's a little preview of doing a couple of things at once here. All right, next one, we're back to Easy Street. And again, let me go back to 2 for just a second. Up 1 means my center line goes from 0 to 1, because where's my minimum? 0. Where's my maximum? 2. What's in the middle of 0 and 2? 1 is. And that's where my center line would be. So no vertical shift, center line stays at 0. Speaking of, vertical shift, none, y equals 0. Amplitude, well, I'm being nice on this one, 1. Okay, period. This time I got to be a little careful. I have a b value. So my period's going to change to 2 pi over 3, which doesn't reduce anymore. But there are no vertical or phase shifts. So not much to play around with here except dealing with the values for my period. And no, you can't leave it as 2 pi over 3 and put this as 0 and know where your points are. I want to know what they are. So what's in the middle of 0 and 2/3? 1/3. Okay. Or pi over 3. 1/6. Now, if that just makes your brain hurt thinking about it, remember, if you're dividing it by 2 to find the middle, it's like multiplying by a half. Multiply by 1 over 2. This stays the same. 3 times 2 would be where the 6 comes from. So 1/6, 2/6 reduced, 3/6, which is a half, and 4/6. And now from here, there's nothing really to worry about, except, am I going to be starting at 0 or 1? Cosine, we're starting at 1. So maximum, 0. Minimum, 0. Maximum. Get my curve in. Now, I'll admit, on number 4, I cheated slightly. 4's done already, so I can explain what's going on here, though. Okay, so on 4, we get the mother lode. We get everything. Everything's going to move around. So, where did I come up with all these values and numbers, and how would you do the same? Okay, so here, I have a shift up of 1, so my center line would be at y equals 1. I have an amplitude of 3. Since my b value is pi, 2 pi divided by pi is where plain old 2 comes from. And then I have a phase shift of left 2. But like we did before, I'm going to ignore the vertical shift and the phase shift until I have the regular part of this graphed. So basically, I'm going to pretend that's my whole problem for right now. And I'm going to plot those points. So if my period was 2, half of 2 is 1. Half in between 0 and 1 is 1/2. So 1/2, 2 halves, 3 halves, 4 halves. And with an amplitude of 3 and a sine function, sine starts at 0. So it goes 0, up, back to 0, back down to -3, back to 0. And again, that takes care of this portion. However, that's not the whole story here. I still need to move these up 1, which isn't a big deal, but left 2. Ooh. If I start at 0 and I go left 2, I have to get all the way out to -2. So basically, I'm just going to take what I see on this side of the axis and I'm going to mirror it on the negative side. Because then when I go to start making my points, I'm basically just going to look and say, okay, my first point was at 0, because here's my initial 5 points. I go left 2, I go up 1. There's my new first point. I go to the next one. Be careful. Left 1, 2, go up 1, make my point. And just keep going. 1, 2, up 1, 1, 2, up 1, 1, 2. Make sure it's not just 2 lines, but it's actually 2, and go up 1 and connect the dots. And again, chart mode you could, but that's a whole lot of chart you're going to be dealing with. But again, this isn't a hugely long quiz, so you're going to have an opportunity to be able to take that time if you so choose. Okay? But that's basically what's going on with the graphing. So again, know your base graphs. Because if you get them backwards, that's not going to be fun. Okay? All right, so now, the back should be the easy part. Should. Let's zoom in a little. Okay, find the reference angle. Reminder, closest x axis, as in 0, 180, 360, or if we are speaking radian, 0, pi, 2 pi. Now, again, think about this for a minute, especially if you jot that down. 300 is closest to, 360.
180. Just kidding.
Y'all didn't hear that. Okay. 60, okay? Now, also be careful, because the negatives are still the same thing. Negative 120 would be close to negative 180. but they're still 60 apart. Reference angles are not negative. Always, always, always positive because they're referencing special right triangles, 30, 45, 60-degree angles. This guy. So now, here's where the danger can come in for some of you. Some of you are going to look at this, you're going to turn it back into degrees. You're going to be like, 2 times 180 is 360, divided by 3 is 120. 180 minus 120 is 60. And then I'm going to write, radians and mark it wrong.
See, that's where this comes in.
This is pi over 3. Or, now there was a good idea. You can use your unit circle because if you come back and you find 2 pi over 3, you're like, that's 120.
Here, I'll just bring one of my samples.
How do I get back? No, you will not bring one of your sample ones. So if it starts radian, it needs to end radian. Negative 5 pi over 4. Again, if you're at 5 over 4, what's the fastest way to get back to one of these? Negative 5 pi over 4. Now you're like, okay, let's see here. 5 pi over 4 would be 225. How do I get back to 180? 45. What's 45 in radian speak? Pi over 4. Positive. Okay, no negatives with reference angles. Okay, convert each degree measure to radians and radian to degrees. Pi over 180. Reduce it. This is going to kill some of you that are going to math enter mode on this. Because I am as serious can be when I say we are not playing with calculators on these quizzes. What? So if you have to, divide by 5, then divide by 5, then divide by 5 if you have to. So there. Or you can attempt to go and back and use the unit circle.
That makes life a lot easier.
My goodness. Hey, let's check this out. 135, 3 pi over 4. What a coincidence.
That is so crazy.
7 pi over 4. Turn it back into degrees. Okay.
Dude, who even needs the test?
Right? I know everything.
Who needs a calculator is what I'm trying to express here.
You're funny, Mr. Harty.
Okay? Now, if you ever want to see the utmost example of overworking problems, look at my old review when we get to this section. Is it on the review? Okay. Again, I'm going to pretend I didn't hear that. So, find the exact value of the trig function. Okay. Sine of negative 135. You're like, well, wait a minute. That's not on my circle. True. But, well, or is it? Okay, let's zoom back out for a minute. If you go negative 135, negative 90, and another negative 45, okay, this is the equivalent of the sine of 225 degrees. And the exact value of the sine of 225 degrees, if you did your unit circle right, is the square root of 2 over 2. I'm going to zoom back in a little because that's really tiny now. Okay. And that's going to work on all of these. Now again, secant of negative 300. Again, think unit circle. Go 300 degrees back. Now I'm at 60. Okay, so this is the equivalent of secant of 60. You're like, wait, I don't have secant in here. What's secant the inverse of? cosine. So let's find the cosine of 60, which is a half. But what do you do with an inverse? Flip it. Okay, what I did was cosine of 60 is a half. Secant its inverse. I flip the 1/2. I get my 2. Okay. The other reason I'll admit that I'm not going to have you doing calculators on this is I get so tired of people writing down like negative 0.8660. No, you don't know what that is off the top of your head, so don't write no decimals to me. Don't give me this 0.866, 0.7071. No, you don't know what that is off the top of your head, so not taking decimals tomorrow. Okay, cosecant of 150 will make life a little easier this time.
Maybe I have a calculator inside of my head.
That's good. Then you can use it. Okay. Here's 150. Cosecant is the inverse of sine. Find your sine of 150. Oops, what did I just do? That's the sine of 150. Do I want the sine of 150? No. I need the inverse. Had to go off and make a mistake. No, we're not going to restart the video. I do silly things on a regular basis. That's just, it's the charm of the videos. Okay. Now,
wouldn't it be negative?
Let's see. 150 puts me in quadrant 2. I'm in sine cosecant land. So I'm in their happy place. So no, it would not be negative. Okay. Next twist. Tangent of negative 120. Okay, let's get the angle measures fixed first. Negative 120, what's that in positive speak? 240. Okay, so let's break this down. It's like dealing with the tangent. Okay, because when we're doing negatives, we go the opposite direction. So if I go, here's 90, here's another 30. Okay. It's the equivalent of 240. But tangent of 240, remember our little note, sine over cosine. You're like, ooh, but this is going to be kind of ugly. Because you're like, sine over cosine is going to be negative square root of 3 over 2 divided by negative 1/2, but it's not as bad as it looks.
Because you multiply by 2.
Because when I flip the second fraction, bye-bye twos.
I still don't like it.
Oh my god. It's magic.
Pretty math. You have math.
Okay, sine of 240, I took right off my unit circle, is the negative square root of 3 over 2. Cosine of 240, took it right off my unit circle, negative 1/2. When we divide by a fraction, it's like multiplying by its inverse, or its flip. Negative times negative makes it positive, and that's where I get my solution from. Okay. Now, here's what I'm going to do for some of you. You're going to be like, what? I'm going to make you practice some of the rest of these. So all I'm going to do for now, I will put answers on for the rest of these. If we get time at the end, because I don't want to rush through the last two parts, we will chat a little bit more. Especially on number 16, which is kind of weird. Because you're going to have division by 0. But we'll get there. We'll come back to 16. We should have time to do that. Okay, so let me scooch this up a little. So then as I keep rolling down here, state what quadrant you are in. I've done a question like this on a quiz before. If tangent is positive and cosine is negative. Okay, let's think about this. Yes, if tangent is positive, it has to be in one of these two. But cosine is negative. Well, cosine isn't negative here. So I'm in quadrant 3. Does this mean that I may go back to the same way I wrote it on the last quiz, where I may say like tangent is greater than 0 and sine is less than 0? Yeah, I might.
Was that all losses? I don't remember.
Why wouldn't it be all?
Because cosine would not be negative in the all quadrant. Cosine would be positive.
Yeah, oh, I do remember. I got that one wrong.
What would... Cosine would be negative, negative, and negative. But it's got to cover both of these. Tangent has to be positive. Tangent's only going to be positive when cosine's negative in this quadrant.
How do you do the next one?
How do you do the next one? Find a value of x where this is true. Sine of x equals 1/2. Well, there's a couple ways I could do this.
Oh, sine of 30.
If sine is 1/2, okay, 30. Is sine of x equal 1/2 anywhere else?
Yeah.
No. 150.
Yeah.
All the 30s, basically.
No, because it's gotta be positive.
Okay. Right, it has to be positive. So don't like start writing down 210 and 3.
What if I write down 56?
I didn't see that.
So don't do it. And then the easy part to finish. Using radians, find the amplitude, your a value, well, except it's always positive, and period for each function. Okay. Amplitude should be the easiest thing you do.
Besides writing your name.
Pretty darn close.
Oh, wait.
That looks like it says 1/9 times cosine.
It does.
And wait, and how's that the
The amplitude is always the value in front of your trig function.
Okay. I thought I had to be like directly in front of
Your b value, remember, is 2 pi divided by b. b being the value in front of your angle measure. So, my period here would be 2 pi over 4, otherwise known as pi over 2.
That's crazy.
But wait, there is more.
Now, will it always reduce down? Not really.
Ah, girl.
And if it doesn't, it doesn't. Now, the one that we're going to revisit for a moment is 16. Because that looks kind of strange. Like, well, how's it undefined? Okay, tangent of 3 pi over 2. Let's peek. So, tangent of 3 pi over 2 would be the equivalent of, again, sine over cosine of that same value. So if I look at 3 pi over 2, okay, sine is -1. Cosine is 0. -1 divided by 0 is undefined.
Just ask Siri.
No. Okay. So that's how we're going to fight this.
Oh.
Fight it?
Fight it.
Like, full on.
Fight the power.
Okay?
Hi.
But again, the quiz will look eerily similar to this. But again, what does it all come back to?
The unit circle.
You know it. Good way to finish.